This is question number 18 from the 3.3 MyLab Math homework. And in this question, we're given a rational equation and we're being asked to find the derivative. So there's actually two ways you can find this derivative. If you work with the function as is, then you'll find the derivative using the quotient rule. Or if you do some algebra to rewrite the equation, then you can use product rule. So I'm going to show you both ways. So let's start with the quotient rule. Let's say we're going to use this equation as it's given to us. Okay, so we're going to start with the quotient rule. Okay, so quotient rule, I need to get organized here. On the top, I have a constant. I have -4, so taking the derivative of a constant will be 0. And then on the bottom, I have a quartic binomial raised to the 6th power. So when I take the derivative of that, I'll have to do power rule with the chain rule because my base is not a plain old variable. It's this quartic binomial. So let's go ahead and do our power rule. Drop the 6 down. I rewrite the base exactly as it's given to me. I decrease that exponent by 1, and then I tack on the derivative of the base. Okay, so let's actually find that. I'm going to rewrite this first stuff and then the derivative of the base. Well, that base is a polynomial function. We're going to follow the power rule. Chain rule is not required because the base is a plain old x and the derivative of a plain old x is 1. But I'm going to do my power rule here. So 7 times 4 is 28. I rewrite the base exactly as I see it. I decrease that exponent by 1. You can tack on the derivative of the base if you want, but again, that's just 1, so you don't need to. And then we have a +1 there, which is a constant, so technically the derivative of that would be 0, but again, we don't need to write that. Okay, and then cleaning this up a little bit, I'm just going to rearrange the multiplication here, so I have 6 times 28x to the 3rd times that binomial to the 5th power. And then I'll go ahead and multiply that 6 times 28 there. Okay, what's that? That's 168. So 168 x cubed. Then I have my binomial to the 5th power. Okay, now I have all the pieces I need to apply my quotient rule. So if I was going to take the derivative of this, my quotient rule says I'm going to do the bottom. So let me write that out. The bottom times the derivative of the top, which was a 0, so I'm just multiplying that by 0, minus the top, which was a -4, times the derivative of the bottom, which was this mess right there. Okay, so that was 168x cubed. Okay, my math lab gave me some yucky numbers this time. All over the bottom, so I'm going back up here to the bottom, going to rewrite that binomial to the 6th power, and that whole thing is going to get squared. Okay, now when I go to clean this up, it's not as horrible as it seems here because I'm multiplying by 0 in this first group, and anytime you multiply something by 0, the result is just 0. So that simplifies the numerator for me a little bit. So now I'm just going to focus on simplifying the rest of this part of the numerator there. Well, first of all, I have a double negative there, so I'm going to end up with a +4. But then I'm going to go ahead and multiply that 4 times this 168. And man, my math lab gave us some yucky numbers, but that's okay. So calculators are for us. So 672 x cubed, and I'm rewriting that binomial to the 5th power. Okay, and then on the bottom, I'm just going to use my power to a power rule for exponents from algebra. So I'm going to take that base, I have it 6 times, and then I square that. So if I have 6 binomials 2 times, I have 12 times. You know, the rule is to keep the base and multiply the exponent, so it's going to be the 12th. And then I can reduce this because I can see here that I have 5 of the binomial factors in the numerator and 12 of the exact same binomial factors in the denominator. So those will divide out. These 5 in the numerator will cancel out 5 from the denominator, and that'll leave a 7 down there. So when it's all said and done, my derivative is 672x cubed in the numerator, and then I just have 7 of those binomial factors left in the denominator. Okay, and we can get this exact same answer by doing the product rule. So let's do that. And I'm going to keep this answer here so we can see we end up with the exact same answer. But instead of using quotient rule, we're going to rewrite our function to do power rule. Okay, so what's that look like? I'm going to rewrite the function. So I'm going to keep the y equals notation because no calculus is going to happen. I'm just going to do some algebra. I'm going to relocate that base from the denominator to the numerator. So there's already a -4 in the numerator, and then when I move that base up to the numerator, that's going to be to the -6th power. And now I can just do my power rule with the chain rule. Okay, I just realized I don't even need the product rule. I mean, technically I could do product rule if I wanted to, but that would be, my first would be a constant, and then my second would be a binomial. And again, when I take the derivative of a constant, we would just end up getting a 0 there. So you could do product rule, but I just realized we can just do power rule, right? Isn't this just set up for a power rule with chain rule? So let's try that. So here we go. We're going to drop this exponent down to the front. So now I'm using my y prime notation because I'm applying the power rule with chain rule. So -4 times -6 is 24. I rewrite that base exactly as I see it. I decrease this exponent by 1. And then I need to tack on the derivative of that base. Okay, so let's see what that looks like. Just going to shrink this answer over here real quick. Give me some more room. Okay, so let's go ahead and find the derivative of that base. So I had 24 base to the -7 power. And then to find the derivative of this base, it's just power rule. That's just a polynomial. So the derivative of 7x to the 4th, I just multiply that down. That's going to be 28x to the 3rd power. And again, if you're adding a 1, that's a constant. So the derivative of a constant is 0. We don't need to write it. And then we'll just go ahead and rearrange. This order doesn't matter when we multiply. So I'm going to multiply the 24 times the 28. Okay, and when I put that in my calculator, I get 672. Then I'm going to put that x cubed next. And then I'm going to put the binomial at the end. And I can see that's the same answer as I got using my quotient rule. All I did in the quotient rule was relocate that base, which we can do. Technically, this is all over a 1, right? So we could relocate that base to the denominator. And when I relocate the base, when I relocate it to the denominator, the exponent changes sign. So that -7 exponent in the numerator would become a +7 exponent in the denominator. So I won't ask you to find the derivative a specific way on the test. I'll just say find the derivative. So if you wanted to work with the equation as it was given to you, you just use your quotient rule and you'll get the answer. If you notice some slick algebra you can do to rewrite the equation and kind of simplify the derivative process, that's okay too. You'll get the same answer either way.